Hello. In this lecture, lecture 4, section 4 is a phylogenetic tree with p-adic variation and 4-point condition. As we see, like the phylogenetic tree is an evolutionary theory is very important because its ranks represent a revolutionary time, and that gives many information about the species. For example, the distance between two species, how far and close between two relation. I'm not a revolutionist. I'm not a revolutionist. I'm not a scientist to study revolutionary theory. And so that is not does not relate to mathematics. But as I said, when we estimate the distance between two species, between D and E, or A and E, like and so on, the p-adic valuation, p-adic metric is a nice model to compute, to estimate between two species. In this lecture, I'll introduce two, when p equals to 2, two-adic valuation. I'll introduce evolutionary model with two-adic valuation. Of course, p is a prime number. And next concept is 4-point. I will discuss 4-point condition that also describe the evolutionary model. Okay, then what is a phylogenetic tree? I'll introduce the definition. Okay. Definition 4.1. A phylogenetic tree is a graph, but a acyclic and connected graph with at most vertex of degree 2, where V is a set of V vertices, and E is a set of edges or branches. As I said, that represent a revolutionary time. Okay, but I'll explain in detail. Detail. When we think about graph, there are 4 types: cyclic and acyclic, and connected and disconnected. Okay? When connected and cyclic graph like this, literally, that is cyclic, and all points is connected. This connected and cyclic graph is like this. Each point is cyclic, but that guys and that guys, that triangle point of triangle at vertices of triangle, the vertices of scale does not connect it. So this is cyclic and disconnected graph. And when you think about acyclic, that does not acyclic literally. But when you think about this point, this is disconnected. That point, each 3 points does not connect to this one. Then our main topic, connected and acyclic graph, is like this. Every point is connected, but does not. This guys is acyclic. This is cyclic. This is not acyclic. Does not come to the origin point. Okay, so our main topic is acyclic connected graph. And what is the vertex? Okay. And when you think about discussed with the graph, that is vertex. Okay. And that is branch. Then, what about the degree? Deleted this here. So, for example, what is it? When you think about following edge vertices consist of A, B, C, D, E, and think about the following graph. That is when this guys is a acyclic and connected graph. Okay. Every point is connected. This one. Okay. That point is connected. And this branch means that E to E itself, okay, connected itself to then that is acyclically connected graph, but that guys is not our main topic, because degree of a degree is not 2. Degree means that if based on A, total branch that connected to each point. For example, when you think about vertex of degree A, then there are 1, 2, 3, that A is connected to D, B, and E. So degree of vertex is 3. Okay? When you think about the vertex of graph E, here, in that case, the graph is connected to A, B, D, and E itself. Note that if graph is connected to itself, we count it plus 2. So, in that case, the degree is 1, 2, 3, and 5. So, vertex of degree E is 5. But when you think about a phylogenetic tree, is the graph acyclic and connected, but the vertex of at most degree 2. So in that case, because of the degree is more than 2, that is not our main interest. Okay, then I explain 2 examples of phylogenetic tree. Example 4.2 is a typical tree, is a rooted tree. And next example is BHV space. Okay, let's see the first example. That is, the graph that I drew in this path is a phylogenetic tree, because that is clearly acyclic and disconnected. Okay, that is trivial. And when you think about the degree, then degree is at most 2. Because when based on this, is 2, and based on this nodes, that is 2. Okay, so when you think about like this, for example here, F, that is clearly not a phylogenetic tree, because in that case the vertex of degree x is 3. Phylogenetic tree is the degree at most 2, allowed 2. Okay, so that is a clearly phylogenetic tree. Among the phylogenetic tree, that guys is a rooted tree. Because so x is called root based on the x, the species x evolves A, B, C, D, E based on the common ancestor. Root is another name is common ancestor, but in a biological reason, some phylogenetic tree is skipped the common ancestor. In that case, we call that phylogenetic tree is unrooted tree. If we don't know or does not denote a common ancestor. Okay? Mainly we think about a rooted tree. That exists we know exists a common ancestor. And these guys from A to E we call leaves, or some calls tips. And that point that branches between 2 species is a node. Okay, and that guys is each line segment is called edge or branch. Edge is classified 2 cases in this lecture. One is internal edge, and the other is a terminal edge. Edge, okay. When internal edge means that that lines okay that is does not connected to tips or leaves, that then we call these edges is called internal edges. And another edges is connected to tips. Okay, that guy is a tip or ribs. Okay, connected to leaves. In the case we call a terminal edge. Okay. If we understand the term internal edge and the internal and terminal edge, we can understand the next example. The more detailed example to describe an evolutionary model that is called BHB space. BHB comes from the name, I don't know spell, Biller, Holmes, and Bachman. So this three space is introduced in 2001 to describe the potential evolutionary model between species. So when you think about n is equal to greater than 3, a BHB spaces represent rooted ancestor as I said, rooted ancestor means there exists a common ancestor labeled for example, roughly speaking, for a phylogenetic, when you think about with n leaves means like this part, there are, that is a phylogenetic tree, there are at most 2n plus 2 edges and n terminal edge. Terminal edge means that connected to leaves, and at most internal edges. So in that case, if n leaves is given, there exists total at most the number of the edges at most 2n minus 2 edges. When you think about if there exists 2 and 2 edges exist, Okay, just at most 2n plus 2 edges, just, okay? Then that is fixed number, and n internal edges, terminal edges, that is fixed. When you think about just this graph, that is 5, okay? But when you think about the terminal edges, that is just 5, okay? But these edges, internal edges is variable. That is at most 2n minus 2 internal edges. So when you think about I will example n3 and n4 like this, and in the case of n4, I introduce two examples of the phylogenetic tree. That is common ancestor 0, and 1, 2, 3, 4 means A, leaves, okay? Then when you think of count the edges, in terminal edges, it's just 3, and internal edges is here. So when you compute a total number of edges is just following the formula. Because it's n is 3, there are four edges, okay? Then in that case, that is a in the case, okay. Oh, no, okay. That is terminal and 2n minus 2. So, sorry. That is not 2n minus 2. That is n minus 2. N minus 2. So the internal edges is let's see, only one. In that case, that allows at most, okay. Let's see the case of n4. Total edges, whenever we consider two cases, the edges is clearly 6. Okay, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Sorry. In the case, edge is 6, but this case, edge is only 5. 1, 2, 3, 4, 5. So when you think about the formula, and in case of 4, we can check that edges is at most 6. Okay, there we can find the case that the total number of edge is need not to be 6. Okay? And when it computes leaves, terminal edges, terminal, whenever the case may be, whatever the case may be, the terminal edges is 4. Okay? 1, 2, 3, 4. 1, 2, 3, 4. Okay. In case of internal edges, in this case is 2 that satisfies 4 minus 2. Okay. But in this case, the internal edge is 1. So, as I said, leaves at most 2 allows 2n minus 2. So, in this case, 6 edges is maximum number. But so there are less than there is the case there are less than 6 edges like this. The terminal is fixed, just n. But the internal edges also at most, so we can find so terminal edges at most 2. So that is a maximum, and if it's not maximum, there are 1, but the maximum number of the terminal internal edges is at 2 when n is equal to 4.